During this initial stage, our team brainstormed many ideas related to geometry and spatial sense. Ideas were mapped onto chart paper for everyone to consider. Discussion is important to this process prior to narrowing down a topic. During stages 1 and 2, we researched and refined our topic through discussion, reading articles, books, and research summaries. We also made connections to our previous inquiry into patterning and algebra. We clarified ideas with each other, asked questions, and made hypotheses about what might work with young children.
I like the idea of geometry, and I think it's huge for visualization, especially the composing and decomposing. I was talking about the polydrawn manipulative that I have in the classroom, and the kids really enjoy it. And being able to visualize something before you stop them together, what is it going to make? But I'm not sure I can narrow it down yet.
Yeah. The geometry appeals to me. It does appeal to me because a lot of it, what we talk about is just what are the shapes, what do they look like. We play with the shapes, we make pictures with the shapes, but I would really like to explore more for my own knowledge, I think.
What else we can do.
Yes.
Kids are still struggling with geometry. I noticed that really last year with my grade 1s, really struggling with the 2D and 3D.
Our team also planned a series of clinical interview tasks. Task 3 ended up informing the direction of the lessons subsequent. Our team planned many lessons to explore how young children were reasoning spatially. In this video clip, the teachers were beginning to connect the exploratory lessons to the public research lesson.
I don't think the younger children understand all the different dimensions that are involved when they're looking at a shape or the orientation.
Mm-hmm.
So doing some things to help them understand that in relation to each other, it's important. You have to look at that, the position. You have to look at the position on the page.
Yeah.
The overall.
The whole team was involved in the planning of the public research lesson. 2 team members volunteered to co-teach the lesson with the support of the whole team. We invited additional guests to observe the public research lesson, including a discussant who is an expert in the field of geometry. 2 of the things that struck us in the public lesson were the use of complex mathematical language, particularly related to spatial orientation and geometric figures, and the levels of engagement and persistence in a task with high cognitive demand. After each exploratory lesson, our team debriefed together by discussing student work samples, describing surprises and challenges, and connecting these observations back to the research and the overall goals of the team. After the public lesson, the team and guests participated in a formal debrief, sharing their observations of the lesson and analysis of student mathematics thinking and learning.
The third task was the one that really led us deeper into a lot of our lessons. We started with some really simple designs using geometric shapes, and we presented them to the children and had them look at it for 5 seconds, and then we covered it up and asked them to recreate it. And the pictures got progressively harder as they went through. We found that this really showed the amount of cognitive load that the children had to handle when they were trying to replicate the design.
During a final teacher-team meeting, the teacher team also reflected on what they have learned about students' mathematical thinking and how the lesson study process had contributed to their professional development as teachers. We also re-administered the clinical interviews to the same sample of students from the beginning of the process. To our delight, all students used more spatial vocabulary in their descriptions, and many improved on the tasks.